Hello ROS students and welcome to the ROS question and answers video series. If you want to learn anything about ROS, this is your channel. ROS Navigation, ROS with drones, ROS with autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning in just 10 minutes of video. I am Alberto Zquedro and today we are going to learn about ROS Navigation and how to easily provide a map that we have created. In this video we are going to basically create a test map, a part of a map, then we are going to save it and we are going to see how we can provide this map with a very easy to create launch file. But before anything else, remember to visit the Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots. No installation required. You will find a link to the academy on the video description. So now let's start with the video. As you can see, I have here several images of maps. There are also maps which are not related to this directly, but yeah, I have searched here in the Google Images for ROS map, and yeah, I have found some of them. For instance, let's open this one. As you can see, this is a map created in ROS, yes, with the Mapping package of the ROS navigation stack. So we are going to see we are not going to see how to create it, but how to provide it. This video will be more focused on how to easily provide this map once we already have the map file created and save it. Okay, so let's go for it. For that, the first thing I'm going to do is to go to the Robot Ignite Academy. As you can see here, robotigniteacademy.com. So I'm going to go to the Academy, and then I'm going to open here the ROS Navigation in 5D squares. There we are. And yeah, I'll wait a few moments until the whole environment of the Academy loads. As you can see, I'm already on the mapping unit, so that's great. Then yeah, basically I have to wait here some seconds. Here I will have the notebook with all the instruction, the exercises, all the theory explained, everything. It will be here in this left side of the screen. Here I will have the IDE, which is the graphical tool in order to visualize all the files that I'm going to be creating, etc. Then down here I have the web shells, the shells in order to execute and to write commands, shell commands. And finally, up here I have the simulation. So as you can see, everything is loaded. The notebook, the IDE, yes, the shells, I have 4 different here, and finally the simulation. All of these windows. So yeah, let's go for work. So first of all, in this case I'm going to do this first part quickly because this video is not meant to explain how to create the map, but how to provide it. So basically what I'm going to do is to launch this first command I have here in the exercise 2.1, which basically, you'll see, launches the mapping node in order to create a map. So yeah, let's execute this launch file. I'm going to also open RVs in order to visualize everything that's going on. I can open here the graphical interface at this button in order to visualize RVs. There we are. So here it's launching RVs. Here we have it. Great. So yeah, let's tune these parameters here. So first of all, I'm going to set here the map display to map in order to visualize the map I'll be creating. Here it is. Now, as you can see, I'm starting to create the map. Let's also here configure the laser to the right topic, which is Kabuki laser scan. There we are. So yeah, as you can see now, I can start moving the robot if I want around the environment, around all the cafeteria here. I can start moving the Turtlebot robot around here, and the map will start to be created. Let's move a little bit the robot. I'm not going to create a full map, but only a small map for test purposes. So let's launch the keyboard teleop program. There we are. And let's just move a little bit the robot in order to create a little bit of the map. So yeah, I'm going to move, as you can see there in the simulation screen, the Totalbot robot is being moved. I'm moving it, I'm controlling it through the keyboard, yeah, thanks to this keyboard teleop program, which is a very common program in ROS. So yeah, so I'm moving the robot around a little bit. Let's see who is going here. As you can see, the map is being created as I'm moving the robot. So okay, for now I think I'm going to, let's complete just a little bit this part. There we are. Let's complete a little bit this part here by focusing the robot there. Let's go a little bit more. Let's see. Okay, yeah. So finally, let me do one last pointing down. So, okay, there we are. Let's move a little bit on that direction. There we are. Let's see if this section gets a little bit of data. Let's wait a little bit more. Okay. So yeah, as you can see, this is a very simple project. So basically, once you have the Gmapping node launched, you just have to move the robot a little bit around, and automatically, using the laser data, all these map will be created. Yes. So yeah, I think I will leave it here because I don't want to create a whole map. This is just a little bit. So okay, yeah. Let's finish it here, but I'm not going to close the program. I can close the teleop program. This one I can close it. And yeah, so now I have this portion of a map created. So what I'm going to do with this is to save it. Let's imagine this is the whole map, okay? So I'm going to save the map, and if you go down here through the notebook, there is one section here which is saving the map. So here it is explaining how to save the map, etc. So basically what I'm going to do is to save my map somewhere around here. Let's say, okay, let's save it here in the source directory so that I can see it here. So I'm going to create here a maps directory. There we have it. And inside this maps directory, I'm going to execute this command: rosrun map server mapsaver -f my map. Yes. So basically, here it's launching the map server node and the map server package. Sorry. And inside this package is executing the map saver node. Yes. And finally, this parameter is to specify the name that you want to give to the map. So let's say we are going to call it my map. So by executing this command, I'm going to create here two files, the mymap.pgm and mymap.yalm. Excellent. And basically these files contain information about this map I have built here. So the mymap.yalm file contains some metadata information like the name of the file, of the PGM file that contains the image of the map, the resolution of the map, the origins, the occupied thresh, free thresh, etc. All of these, what this means, etc., you can find it here in the notebook. Everything is explained. I'm not going to stop on this now. And yeah, and then you have the my map PGM, which is basically the image of the map. So for instance, I can try to do, let's download this file, this my map PGM. And I'm going to open this file, the my map PGM file, which I have just downloaded, and there we have it. As you can see, this is basically an image, yes, of, let's put it here better to compare. Yeah, so as you can see, this is the exact same map that I have just created here. Yes. Excellent. So yeah, now I already have the map. let's close this. Yes, so I already have the map. I can close everything. Let's close, well, let's see if RV is, well, let's close it also. Doesn't matter. I'm going to close the mapping node. And now, what should I do in order to, if I want to provide this map? Yes? Okay, so you have a couple of methods. Here also they are, yeah, here is the explanation of these files, the BGM, the YALM file, as you can see, everything is here. Now here we have the providing the map section. Yes? So basically, as you can see, you have a way of doing it through a simple command file. So for instance, I could, let's come here to the maps section. Okay. So for instance, I could come here and execute this simple command here, ROS run map server in this case. Remember before we were using the map saver node, here it's the map server node, and then we just specify the name of the file, of the YALM file that I want to provide. Yes, of course you need to be in the directory where your YALM file is, or specify the full path. Either way. So I'm going to execute this command now here. And as you can see here, it's a loading map, etc. So now I can come here to RVs. Let's launch RVs again. There we are. And now if I select here the correct topic, which is map, let's put it there. Oops, sorry. Map, there we are. So now I can visualize here, I can perfectly visualize the map. Yes, that I have saved. So I'm providing this map. Okay? Then, okay, and there's another way to do it, of course, which is through a launch file. It will be also explained here, so I think it's here. Create a launch file that launches the map server node. Great, so let's do this. Let's create this package. King create package provide map. Let's create it here. There we are. And let's here add a launch folder and a launch file, which I'm going to call provide map.launch. There we are. Then let me move. I'm going to move the maps folder to this provide map package better. So I have everything here into one single package. So yeah, so now I have my maps inside the provide map package. And now let's see if I have here any kind of example. No, it isn't. Okay, so don't worry. So let's create from scratch our launch file. It's very simple, as you will see. So first of all, let's set this to XML, by the way, which will make easier the whole process. So first of all, we need to create the launch tag, and then let's create a node tag, as always. And here, you will have to select, first of all, the package, which you already know from this command. The package is map server. So let's specify here map server. The name of the node, you also know it. It's map server in this case, yes. So always you have a ROS run command. The first, it's the name of the package, and the second one, it's the name of the node. Yeah. Then finally, we will specify the name of the node, which in this case it's also map server. So everything is map server, as you can see, quite easy to remember. And then finally, we are going to add an args attribute here. Yes. Then in here we will specify arg the map file, let's say, that we want to load. Okay, so we have the name of the package, which is map server, the name of the C++ executable in this case, of the program, which is map server, and the name of the node, which is map server. But of course, for executing this, as you can see from the command, I need to specify a name, the name of the file that contains the map that I want to provide, yes? So this is why we are adding here this argument, yes? Which in this case will be called map file, okay? Then before this we will need to add an arc, yes? So which will be called map file, yes? Then finally we will have to add here a value, which can be, for instance, in this case it would be home user tracking workspace src maps whatever my map.yal, yes? So in this case, let's check it out here. If I do a ROS cd provide map cd maps, yeah, here you have the full path, home user tracking workspace src provide map maps. Let's just copy it here to make sure. Yeah, we forgot the name of the package actually. So this would be the wall path to the my map.yal file, and this will give the value, this value, to the map file argument. Yes, so basically here we will be loading everything and passing the name of our map file. Okay. Anyways, this is not the recommended way of doing this. There is a much more better way of doing it, which is this one. Let's remove this and add here this find and provide map. So basically what this does is to find the provide map package, and then inside this package it goes to the maps folder and then the mymap.yal file. Yes? And yeah, that's it. So we are defining this map file argument. Basically, we are giving it the value that we want, in this case the map we have just created, and then we are loading this map into the map server node, yes, in order to provide it. So let's save this and let's execute this launch file. So ROS launch provide map.launch. Let's execute this launch file. There we are, excellent. And now let's open again RVs to see if everything is working fine. Okay, I don't think this is my RVs. Okay, now let's start from zero. ROS run RVs. There we are. Okay, now yes. And then let's again modify here the topic to put it to map. And there we are. So here we have the map that we have created provided through a launch file. So two very simple methods. Usually when developing in ROS, you will use this method. Yes, because you will use this alongside other things. For instance, you will launch the AMCL nodes, the move base node, yes. And for using, for instance, localization or path planning, you will need to provide a map. So you will include this section here into localization or path planning, yes. And usually this is the way of doing it. So through a launch file, okay. And yes, that's all. So in the description of the video, you will find a link to the complete course about ROS Navigation, which is this one here. Here I'm in the mapping unit, but as you can see, we have some basic concepts, localization, path planning, project, etc. You have everything about ROS Navigation in this course, so I will leave the link to this course in the description of this video. And yeah, that's it. So, did you like the video? If you like it, please give us a thumbs up, and remember to subscribe to our channel and press the bell for a new video every day. Either you like it or not, please share your thoughts and questions in the comments area. Goodbye and see you in the next video.